Alright, ladies and gentlemen, let's dive into a lesson about solving simple exponential equations. We already had number one, but now we're going to do number two. Number two, as you can imagine, is a little bit more complicated than number one. Weird, I know. But yeah, a few things to remember. So we talked about this last time, that if your bases are the same on your equation, and you have your two exponents, if the bases are the same, then the exponents have to be the same, and so we would effectively just drop the bases and put equals. And it works with numbers, right? If you got 5 to the x, and the other side's 5 to the negative 6, then you can drop the 5's, and your answer is going to be that x is negative 6. Well, the same is true that even if you have more complicated things, let's say we have 5 to the 4x plus 2 power equaling 5 to the negative 6, you can still just drop the bases and set the exponents equal, which you can then solve. So we got 4x plus 2 equals negative 6. You can finish solving, you just subtract some 2, and you got 4x is negative 8, and you can divide by 4, and you got x is negative 2. Hooray, we finished it, we solved it. Yay us. Alright, so that can happen. Which, and speaking of it can happen, it's going to happen. That's what pretty much this assignment is. And so we're going to go through a similar process as yesterday. You need both sides to say 2 to something equals 2 to the other something. I'm going to do a backwards question mark because reasons. Yeah, we want both sides to say 2 to a power. We want them to have the same base. So I'm going to delete this real quick. Well, left side already has 2 to a power, and the right side just says 4. Well, we can rewrite 4 as 2 to a power. It's just 2 squared. You know, because 2 times 2 is 4. So we're going to rewrite the right side to be 2 squared. And the left side is staying the same. But now we got this. We have bases that are the same, which means our exponents have to be the same. And so we're going to cross this out. We're going to drop the bases. And now we got 2x minus 4 equals 2. And now we need to solve this. This is a pretty simple equation. You need to get rid of the 4 and get rid of the 2. Pause the video, see if you can finish solving that equation. Did you solve it yet? Because all you did was add 4. Now we got 2x is 6, and you can divide by 2. And now we got x is 3. Hooray! Answer! So yeah, if you were to put 3 up here, right, you have 2 times 3, which is 6, minus 4, which is 2, and you get 2 squared equals 4, and that's true. All right, our answer worked out. If you plug it back in the equation is true. Sweet. All right, well, let's jump to a different one. Let's jump to... Actually, I want you to go to number 4. Sorry, number 4. Number 2. Go to number 2 and see if you can figure it out. Go ahead, pause the video, and give it a shot. Did you get an answer? Because the right side comes out to be 4 to the 3rd power. And so we can drop the bases. Now we got 3x minus 3 equals 3. And now we can add 3. And we got 2x equals 6. And you can divide by 2. And you get your answer. X is 3. Hooray. If you're getting that, good job. It seems like you know what's going on with this whole thing. All right. Now time for weird ones. Okay, let's go to 4. So 4 has this scary thing. It's called a fraction. Please don't panic over fractions. They're not that big of a deal. If you remember yesterday, the way we dealt with it was we just pretended it wasn't a fraction for a little bit, figure out what power it is, and then just make the power negative. Because negative powers are what give you fractions, right? If you got 3 to the 12th, negative 12th power, that's equal to 1 over 3 to the positive 12th power. This is not the answer, but that's how you get fractions. They just come from negative powers. And so I'm going to take this, I'm going to delete it so it's not in our way. Now we just need to rewrite the right side as 3 to a power. Well, let's look at 81. If you divide by 3, you get 27. You divide by 3, you get 9. Divide by 3, you get 3. All right, it takes 4 3's times together to make 81. And so the right side is going to be 3 to the 4th. And then we just make it negative, and that's how you get the fraction. All right, there's our right side. Now we got 3 to the negative 3x plus 2 power. I want you to go ahead and finish solving this problem. Pause, get it done. Did you get an answer? Huh? Did you get an answer? You should drop the bases, and you get this. Exponents are equal to each other since the bases are the same. So now you can subtract some 2, and we get negative 6 on the right side. You just divide by negative 3 to get your x by itself, and now you got x is 2. I feel like we've already gotten x is 2. No, we got x is 3 a couple times. Okay, hooray! So there you go. If it's got a fraction, just realize that the exponent has to be negative. All right, so we've done that. Now we're going to do one more extra level of complexity dealing with this concept. So we're going to go to the next one. We're going to go to 8. We're going to do a little bit of solving. Just like yesterday, if you have more than one term on a side, you need to make it so it's only one term. And so we're going to get rid of this plus 13. You just subtract it off. No big deal. And now we got 1/16 to the x power is equal to 64. All right, well, now I need to convert the right side to be 1/16. And so I'm going to try to divide by 16. When you divide by 16, you get 4. And this is where we run into a problem. Because you can't take 16 and write it as just like a power of like 1 or 2 or something like that and get 64. No integer exponent is going to get you there. And so really what we need to do is we actually needed to change the exponent, change the base on both sides. What I see here is that there's a 4 and a 16. And, through all my years of experience dealing with all these multiples, powers of things, I realized that 16 is a multiple of 4. So I'm going to divide it by 4, and I get 4. So really, if I want to get 64, I can write that as 4 to the third power. So I'm going to do that. This is going to be 4 to the third power on the right side. I am also going to change my left side to be 4 to a power. So I'm going to take 16 and divide it by 4. And you get 4. Awesome. It's 4 squared over here. But it's a fraction. And so I'm going to rewrite my fraction as 4 to a power. And if you're going to get a fraction, you just need to put your power as a negative. So our left side is actually going to be 4 to the negative second power. But it still has this x exponent on the outside. Remember to keep your parentheses. They matter. They make a difference. So now I got 4 to the negative second power to the x power. If you have a power to a power, you times them together. That's something we did a couple days ago. A few days ago, you just do times them together. So our left side is going to be 4 to the negative 2x power. Negative 2 times x is negative 2x. So hooray, now we have bases the same on both sides. And you should be able to finish. Go ahead and finish solving this problem. All right, did you finish solving? Did you drop the bases and get negative 2x equals 3? And then divide by negative 2? If you didn't, that's all you had to do. You just had to just drop the bases, set exponents equal, and then divide by negative 2. This does not go evenly. And so I'm just going to leave it as a fraction, and that's totally fine. We just call it negative 3 halves, and that's okay. You can get fractional answers. It's fine. Fractions are numbers too. And there we go. So there you go. If you got weird bases and they don't match up, you can't get them to match, you can change both sides' bases. And if you got fractions, remember you can use negative exponents. And if you have an exponent to an exponent, you multiply them together. So a lot of different properties getting used here. But yeah, those are the examples I wanted to go over with you. Good luck on the rest of the assignment, and may the force be with you.